Okay, so for today we're going to be looking at some probabilities using z-scores, something we talked about last week. Last week we looked at using the empirical rule to find probabilities. Now we're going to look at what happens if it's not an integer value for the z-score. What if it doesn't hit exactly on one of those where we could find this percent doing the empirical rule? So this table that you see on here is how we're going to look these things up. So we're going to calculate the z-score and then use the table to look it up. This is a portion of the table. You have the entire tables on pages 8 and 9 in your notebook. So I would suggest open your notebooks, pages 8 and 9. Have that sitting out because we're going to be using those tables throughout today's lesson. So when you get there, you'll notice on page 8 are all the negative z-scores. Page 9 is all the positive z-scores. What does it mean if a value has a negative z-score? What is its relation to the mean? Lower than the mean. And if it's positive, higher than the mean. So we're going to use these tables to calculate the probabilities, okay? We'll just look up the values on there. So this first page, we're giving you the z-score, you're just finding the information. So on this first one, we're looking at a z less than negative 0.75. So when we look at our normal distribution, which is sketched for you, the z-score in the center is 0, and then positive z-scores are to the right, negative to the left. So we're just going to label those z-scores. And then if we are estimating where this negative 0.75 is, it's going to be between the 0 and 1, a little bit closer to 1. You don't have to be super precise, you just want it to be between the right numbers. So I'm going to say it's about right there. Then if we're looking for values less than, I'm going to shade to the left. So I'm going to shade all of this over here to show that's the reason I'm looking at. Then since this is a negative z-score, I'm going to be looking on page 8, and I'm looking at negative 0.75. So the integer part in the first decimal place is over here on the left. The second decimal place is across the top. So if I'm looking for negative 0.75, I go to negative 0.7 on the left. Then at the top, I find 0.05. And then I trace those across, and I come up with there's my probability, 0.2266. Okay? So that's how you're going to use the table. So my probability, when I write that over here, the probability z is less than negative 0.75 is 0.2266. So just get that straight from the table. Questions on that one? Everybody see how to get that number from the table? Okay, let's look at the second one. This one we're looking at z greater than 1.5. So I'm going to label my z-scores across the bottom. So I have a positive 1.5, so it's going to be halfway between 1 and 2, so about right there. And I want z greater than. Okay. Shading to the right. So this time I have a positive z-score, so I'm going to be looking over on page 9. But we notice when we look at page 9, this graph at the top shows it's shaded to the left. Both of the z tables are for area to the left. I'm looking for an area to the right. So here's what I do. When I look up negative 1 or positive 1.5, I get this value right here, 0.9332. That is the area over here that's not shaded. So I'm going to do 1 minus that. Because if the total area under the curve is 1, I can subtract the not shaded part and get the shaded part. Okay, so anytime you're looking for an area to the right, you want to do 1 minus the table value. Okay. So I get 0.0668. So the probability is greater than 1.5 is 0.0668. So far good? Questions? Okay. So part C, now we're looking for a z between two values. So I'm going to label my z-scores. So negative 2.13 is about right here. Positive 0.54 is about right there. And I want it to be between those. So I'm going to shade in between here. So now I'm going to look up both of these values on the table. So whenever I look up this 0.54, I go to 0.5 on the left, 0.04, where those intersect 0.7054. Okay? So that's telling me from this point over this way is 0.7054. When I look up this one, it's telling me this area. So when I look up this negative 2.13, I'm going to get 0.0166. So if I want to find the area in between them, I just take this amount, which was from here all the way over, and I subtract this area that's not shaded. So I'm just going to subtract those two. Anytime you're looking for an area between, you're going to find each z-score, find the probability for each one, and then just subtract them. This probability that you end up with should always be positive. So you're always going to take the bigger number minus the smaller number, okay? Because your probability should always be positive value. Okay, so the last one. I'm going to label my z-scores along the bottom. So this negative 1.4 is going to be about right here. We want z less than that, so we're going to shade to the left there. Or we want z is greater than 2.05, so over here. So this one over here at negative 1.4, I can look this up on the table and it's going to give me area to the left. When I look that up, I get 0.0808. When I look up this one, it's going to give me from here all the way over. That value is 0.97998. So 9798. That's from here this way. I want to know this other side. So I'm going to do 1 minus that. So that's this area out here on the tail. So if I want the probability of being in this shaded area is the 0.0808. This shaded area is 0.0202. If I want to know the probability of being in one or the other, I just add them together. So that's going to be my probability of this entire situation. Because, yeah, the table gives us 4 digits, so we just use all 4.
Oh.
Yeah. Good question. Anybody else questions so far? Okay, let's look inside. So this was inspired by Miss Temple across the hall. Has some pet ferrets. And so we know the mean length is 14 inches. Okay, so that's our mu is 14 inches. Standard deviation is 0.9 inches. So I usually just write that down somewhere to the side so I don't have to keep reading through the paragraph to find the information. If you don't write it, that's fine. It's just, it's nice to have it separated there. So, this first part says, what is the probability that a randomly selected Jill, which is the female ferret, is less than 15 inches in length? So we want to sketch this situation. So we know the mean is 14, so that's going here in the middle. The standard deviation is 0.9. So this is 14.9. We want more than 15, so we need to do this again. So 15.8 is the next one. So it's going to be in between these, kind of closer over here when we get 15 inches. And we want the probability that it is less than 15 inches. So we're going to shade to the left. First thing we want to do, after we've done the sketch, we want to find a z-score. So you get the z-score by doing the mean value, which is 14, do the value, 15, minus the mean, 14, divided by standard deviation. And we want to round this to 2 decimal places because that's what is available to us on our Z table, is we can only look up Z-scores up to 2 decimal places. So we want to round to that. Then we're going to look this up on our table. So 1.1 on the left and then over to 0.01. Now, what I usually do at this point, instead of writing probability Z is less than this, I put it back in context. So the X value, I want to know when is the actual length less than 15 inches. Here you can either write it in terms of Z or in terms of X. I usually use X because we're going to go back to context at the end anyway, and it kind of starts putting it back into context. But it's kind of a personal preference. So we want to look up this 1.1 on the Z table and see what is the probability getting less than that. When we look at 1.11, I get 0.8665. When we write our answer in context, I always go back to the question that was asked. What is, and then the probability that a randomly selected GEO is less than 15 inches in length. That's my context that I'm going to use here. I just write it verbatim down here into the answer. So the probability see, I just used exact wording from the question and then just put is and gave the probability that I've calculated.
You could do like every time.
You could. Anyone else questions? Okay, let's look at part B then. This time we want to find the probability that a randomly selected GEO is longer than 13.3 inches. So the 14 is here in the middle. If I subtract 0.9, I get 13.9, and this would be 12.8. So it's going to be in between there. The 13.3 is going to kind of be in here. So you always want to label that line that you draw as your boundary with the value that they give you in the problem. Oh yeah. Thank you. Oh, over here. Yeah. Oh my goodness. Is it Monday or is it Monday? Okay, so that's 13.9. Okay, well let's just, we're not going to be there. We're going to be way over here. So 13.3. Okay, how about that? So this time we want longer than, so we're going to be shading, excuse me, on the right. And we'll find the z-score using that value. So the 13.3 minus the mean divided by standard deviation. Negative 0.78, and you want to round that up. It was like 0.7 repeating. I want to round that at the second decimal place, so negative 0.78. So the
probability of getting an x value greater than 13.3 is 1 minus, because we're shaded to the right, so we're going to look up the value on the table, and that's going to give us area to the left, so I have to do 1 minus whatever the table value is for this negative 0.78. .2177. This is our probability greater than 13.3. So to write it back in context of the problem, I just go back to the question. That's my context statement. Put in 0.7823. We're still doing okay? Okay, let's look at this last one. So we've got 14 and we have 13.1, 12.2. So this 12.5 is going to be in between there. And then 14.5 is going to be right in here. We want between 12.5 and 14.5. So I'm looking for this probability right in here.
Do I find previous
So this time we're going to find a z-score for the 12.5 and a z-score for the 14.5. So we'll have to find both of those over here. So when I look these up on the z-table, this value here, the negative 1.67, gives me a value of 0.0475. And this one up here, the positive 0.56, gives me a value of 0.7123. So to get the value in between, we're just subtracting those values. Answer in context just comes straight out of the problem.
Okay, so on the other page, you'll see that you have 4 boxes. I'm going to give each group a practice problem. This will go in one of those squares, and then you can just trade out to get another practice problem until you've done all 4.